In the last class, we have discussed about electric charges and Coulomb's law. In this class, we will do some problems based on those topics. First problem, the electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 8 microcoulomb. I'll write here it is minus 0.8 microcoulomb. In air is 0.2 Newton. What is the distance between the two spheres? What is the force on the second sphere due to the first sphere? We will try to solve this. Two spheres are given, 0.4 microcoulomb and minus 0.8 microcoulomb charge. Let me say Q1 is 0.4 microcoulomb. Other one is minus 0.8 microcoulomb. They are separated by some distance. That distance we need to calculate, R. And the force when they are placed in air is 0.2 Newton. So first let us write the given quantities. Given Q1 is 0.4 microcoulomb. Q2 is, I'll write small q2. Q2 is minus 0.8 microcoulomb. And we need to find out the distance between the two spheres. That is the question number E. R is what? The distance between the two spheres. And given also F is 0.2 Newton. We can easily calculate using Coulomb's law. Fs by Coulomb's law. I will write here what he has given is the force on small sphere due to another small sphere. So while writing F, we will write F on sphere 1 due to sphere 2, F12. So according to Coulomb's law, F12 can be written as 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Substitute all the values. F12 is 0.2. We know 1 by 4 pi epsilon naught is 9 into 10 to the power 9. What are the two charges? 0.4 micro and 0.8 micro. 0.4 micro. You know micro is 10 to the power minus 6. Multiplied by minus 0.8 micro, we can neglect minus sign because we are calculating only the magnitude of the force. The minus and plus sign can be used to find out the nature of the charge. Divided by R square. So R square will become 9 into 10 to the power 9 into 0.4 into 10 to the power minus 6 into 0.8 into 10 to the power minus 6 divided by 0.2. Do the calculation. So here 10 to the power 9 10 to the power 9 minus 6 minus 6. So that will give you 10 to the power 9 minus 12. That means it is 10 to the power minus 3. Then calculate the other things also. 9 into 0.4 into 0.8 divided by 0.2. So finally it leads R square is 14.4 into 10 to the power minus 3, or this can also be written as 1.44 into 10 to the power minus 2. Take square root, you will get R. R is 1.2 into 10 to the power minus 1 meter. The distance between the two spheres to get a force of 0.2 Newton is 1.2 into 10 to the minus 1 meter. Now the second question is, what is the force on the second sphere due to the first? Force on second sphere due to the first. We know the question is force on second sphere due to the first equal to what? We know F21 is equal to F12. The two forces are equal in magnitude and opposite in direction. Therefore, F21 is equal to F12. So, F12 is given, that is 0.2 Newton. Always you need to mention the unit. Don't forget to write the unit. The force is of attractive type. You can write here attractive force also. Why it is attractive? Because we have one positive charge and one negative charge, unlike charges. That completes this problem. Next we will see another one. Given here is a problem. A polythene piece rubbed with wool is found to have a negative charge of 3 into 10 to the power minus 7 Coulomb. Estimate the number of electrons transferred from which to which. Is there a transfer of mass from wool to polythene? In the last class we have seen when two bodies are rubbed together, the electron gets transferred from one body to another body. So this problem is based on that. Recall the properties of electric charges. The charge is quantized. Because charge is quantized, we can always write charge Q is N into E. So this N is any integer. We can use this equation to find out the number of electrons transferred. Number of electrons transferred N is equal to Q by E. Q is the total charge transfer, that is 3 into 10 to the power minus 7, and you know the value of E. Three into 10 to the power minus 7 divided by E is 1.6 into 10 to the power minus 19. Minus 7 minus 19. So it will become 10 to the power plus 12. Then 3 by 1.6. N will come equal to 1.875 into 10 to the power 12. Is there any unit for this? No, because it is a number. N is an integer. So number of electrons transferred is 1.875 into 10 to the power 12. From which to which? How do we say from which to which? Because in the question it says polythene piece rubbed with wool is found to have negative charge. So polythene piece is negatively charged. That means the polythene has acquired the electrons, or electrons have from polythene, because polythene is negative charge. Electrons are wool to says transfer of wool to there is, because electrons have some mass, this is transfer. There is a mass transfer. So you can calculate what is the total mass of electrons which have transferred from wool to polythene. Mass of, we know the number of electrons have transferred, 875 into 10 to the power 12 electrons is equal to mass of electron by number of electrons. So we know the total number of electrons transferred is 87 into 10 to the power 12, and the mass of an electron is 0.2 10 to the power minus 30. Okay. So here this is what 1.1 into 3. So this is nothing but mass of 1. Right here mass 1. This is just for your note. 9.1 to the power minus 31 kg is nothing but of 1 electron. So you will get the total mass transferred. Calculate, so you will get it as 0.71 into the power minus k. That mass has transferred from wool to thin. At the end, right? So total transferred from polythene is 1.71 into power minus 8 kg.